Hey, Alan.
Good morning.
Morning, hi.
It's always very confusing about Alan having two windows. I always thought that we have 4 people in the call. And then I look at it, it's...
Morning. Morning.
Morning, Michael.
Morning, Michael.
Good morning.
Perhaps we should start, because I heard from Fabio that he's busy, he has a conflict, so he may want to start. Let's give it a minute. Alan, in terms of the agenda, I think you posted something. Or should I update anything, or is it already in there? No, it's updated. Okay, I updated the agenda. All right, shall we go ahead and get started, folks? What do you think? I cannot hear you, Alan. I don't know if I'm the only one or...
Yeah, I can't hear Alan either.
No, I can hear hi and Michael.
Okay, can you hear me now?
Yes, perfect.
Sorry about that. I'm trying to hold that.
All right. Okay.
Yeah, we can get started.
Oh, there is a sync issue. That's gonna drive me crazy. There is a difference between your lips moving and your sounds arriving. So, all right. Anyway, let's get started. I'm going to share a screen. Let's turn off other things. Share my entire screen. Okay, so I think the first item on the agenda today is a quick recap of 0.8 and load testing in particular in 0.8. So let's jump in. So as we know, 0.8 brings in a whole lot of changes in terms of simplified usage of Iter8. And the preview version starts with a simple experiment, load testing experiment. That's where we are starting because it is a simple experiment to get, from a development perspective, it is simpler to get started there. That's why we're starting there. And over time, we will add support for all these other iterate experiments that we are all familiar with. So all of that will become part of 0.8 in the next few days and weeks. But let's get started with the load testing. All right. So the best way is to actually go through a couple of demos, and then we will be able to see the key differences between 0.7 and 0.8, and in what ways 0.8 actually makes things easier. Right, okay, here's the quick start experiment for load testing. Right off the bat, you can see that there is a brew install of Iter8. So that tells you that Iter8 is now a local, there is at least a component of Iter8, which is a local command line utility, which you can just, very, very simply install this way. I already did my Iter8 install. So I do have my brew install Iter8 done, but let's do it, let's uninstall it and install Iter8 following these instructions.
Do we have documented also how to update Iter8?
Yeah, that's a good question. It's as simple as brew upgrade Iter8. That's all it is. However, it needs to be documented. It needs to be documented. So you're right. So maybe just make a note of it somewhere as we do this, or even better, create an issue. I feel we need an issue for this. I think that's true for all these, except for binaries. I think you don't need to do anything different for binaries. You just put it in the normal place. But
also maybe, not for go install.
Maybe I think we can get away with just this for go install. But even then, I would like to document it, so that it's clear that nothing different needs to happen for upgrade. But you're right. This is a good point. Okay.
I think for brew, it's especially necessary because we are changing it so frequently.
Right. Right. Of course, the brew install formula itself is automated. So when you release a new version of Iter8, the formula itself upgrades. So there is a new way to, this Iter8 CI takes care of upgrading brew. However, the user has to write an upgrade command instead of an install command. So it's worth documenting there. Okay, so the second is the notion of an experiment chart. In Iter8 0.8, every experiment is done through an experiment chart. And the idea of experiment chart is very similar to a Helm chart. As a matter of fact, under the covers, experiment charts are Helm charts. And it has one interesting consequence, which is, by definition, it's a reusable thing. So a Helm chart, as you know, is something that can be combined with the different values to produce different manifests, and to create different manifests. Reuse the same chart with the different values to create different manifests. That's the concept of templating in Helm. And the same thing holds true for experiment chart also. You combine the chart with the different values to produce different experiments. So just by design, the experiment is the reusable piece here. So let's get the chart. And there's a little command here that makes it easy to get charts from this thing called hub, which is where all the Iter8 experiment charts are stored. Right now, there's only one chart in that hub called load test. So we'll go ahead and grab that. Chart. Okay, so we got the chart, and we are now in the load test chart folder. And if you're curious, you can actually look at what is in there. It's very much what you would see in a Helm chart. And it's also documented the same way as a Helm chart. So the concepts of README, values file, documenting the values file, everything is inherited from Helm chart documentation. So we can do all of this. Okay, now let's actually run the experiment. Here we are going to, experiments are meant to be run from the root of the chart folders. So we already are in the root of this chart, load test chart. So let's go ahead and run the experiment. As we mentioned, an experiment is what you get when you combine the chart with values. In this case, we are load testing this particular service hosted at this URL. And we are checking for these SLOs. We're going to do a load test. So we're sending it load. And then based on the responses, we're asking, is the error rate 0? Is the mean latency 50? P90, 90th percentile latency less than 100 milliseconds. 97.5 percentile is that less than 200 milliseconds. So SLOs are specified as part of these values, and the URL where we are load testing is also specified as part of these values. So experiment is over, and we can, oh, by the way, it does produce, when you do this run, there is a experiment object that is getting created. So you can take a look at what that object is by just looking at the experiment YAML. And you can also look at the results produced by the experiment. So this is where the actual results of the experiment run are stored in the results file. Frankly speaking, neither the experiment YAML or results YAML are meant to be consumed directly by end users. Of course, developers need to understand what these things are and need to know what to do with it. But end users are just meant to use the chart with values. That is the key concept here. Okay, so assert outcomes. We can assert if the experiment, oh, not all conditions were satisfied. SLOs were not satisfied. So we can assert outcomes and check whether, experiment completed, there were no failures, and where the SLO specified in the experiment satisfied. Looks like the SLOs were not satisfied. Why not? Maybe the experiment report will tell us why not. So here's a quick way to generate a nice visualizable HTML report from the experiment we just did. And let's take a look at it. And oh, this P97.5 got violated because we can see a few here. So there were a few, that couple of queries that went to 200 range, couple that, yeah, there were 3 queries. Looks like there were 3 that, oh, this is not, maybe there were a few that went above this 200 number, and that's why it failed. So this particular SLO is simply not satisfied. That's why the experiment simply failed. We will look at a few more examples. Hopefully in those examples, we will see some, SLOs actually getting satisfied. So we will be able to see them also. Anyway, this, in short, is the concept of an iterative experiment now. You start with a chart, run it with values, assert outcomes, and view report. Let's take a look at a few other variations that you can do on top of the experiment that we just did. So you can control how the load is generated. For example, you can control the request generation process by setting the number of queries, by setting the queries, requests that you're sending per second, by setting the number of parallel connections that you're using. So the Helm chart now makes it drop dead simple to set all these things. So this is how this works. And let's see. I would expect it to fail again because it's the same SLOs. But experiment completed. In this case, num queries, QPS connections is what we are setting. Oh, once again, the assertions fail. That's what we would expect. Anyway, that experiment, this new experiment is also over now. So let's take a look at something else we can do. We can send payloads as part of the experiment. So this is an interesting variation. And to exercise this variation, let's actually create the sample app that will accept payloads. So I'm going to go here and run this HTTP bin application that is running now, and it is willing to accept payloads, so we can actually do our load test with payloads. I'm just going to send a payload called a string payload called abc123 to this particular endpoint. Let's see how that works. Okay, so once again, it's just the URL that is different, and also the payload. Now it's a post request. So this is actually, since you're specifying a payload, Iter8 automatically is going to be sending post HTTP requests to that particular endpoint. And let's see this time if the SLOs were satisfied. Oh, good. So this particular service, which is running locally, maybe not enough, maybe there is not any load or much load or anything. So this is working well, and all SLOs are satisfied in this particular case. So all good.
Sri, quick question. Maybe I missed something. What exactly is running on this 127.00.1/post?
I just started this HTTP bin application.
Oh, you did? Oh, okay.
Yeah.
Okay.
No problem. So this was an application that it's a famous application for HTTP testing. So I'm just starting that for exercising this payload option. That's all the purpose is. We can do other things, other kinds of payloads. For example, we can download payload from a payload URL and then use that payload as part of your experiment. So here we are going to download an image file, this particular image file from this URL. And then for each request in our load test, we are going to set the content type as image/JPEG and then use that downloaded file as the payload, image file as the payload. Of course, the download of the image file happens once at the beginning and reused again and again as part of each request in the load test. So those optimizations are handled by Iter8 for us. So let's try it. This is a very flexible application. It will accept any type of payload we send it. So that's why we're using that for demonstration purposes. So once again, the experiment completed. Once again, I'm asserting that SLOs are satisfied and everything is good. We are able to download this payload, send it, and use it as part of the load test. You pretty much any payload that you want to send, you can send this way with the appropriate content type for your application. One final thing here is how we exercise the SLOs, and how we set the SLOs and the metrics for SLOs. So let's take a look at this example. Once again, we're going back to example.com. The idea is very simple. There are a couple of metrics, 3 metrics that are built in: error rate, mean latency, and error count, and also a whole bunch of percentile metrics. And essentially, you can specify any percentile that you want. Iter8 will automatically compute those percentiles and evaluate the SLOs you specify that for that percentile. That's all there is to it. Here, P90 is something that is by default computed by Iter8. 97.5 is not computed by default by Iter8, but since you specified in an SLO, the chart is made in such a way that it will pick this up, add it to its list of percentiles that it's computing, and compute it. So essentially, you can just whatever percentile you want to specify, you can specify it and specify a limit on top of that, and that's all there is to it. There are some other examples here for Knative. Once again, it's just a Knative. It's the same thing, but it's just that the HTTP service is now created using Knative. That's all the difference is. And incidentally, I submitted a PR to the Knative community around by just giving a link to this particular tutorial. The PR is merged in Knative upstream repo, but I don't know when it will actually show up. Maybe whenever they have their next release, it should show up, or maybe it has already shown up. I will follow up, but I know that the PR got merged, but I just have to see when it becomes visible publicly in the Knative documentation. That's about load testing. Let me pause here, see if there are any quick questions, or else we can move on. We have to remember. Michael, can I request you to create that issue that you brought up? I think we need that.
I already did.
Oh, great. Good. Very good. Okay, moving on to the next item in the agenda is Abn testing. And I actually put together, I forked the Iter8 repo and started writing some version of how we want the Abn experiments to look like in Iter8 v0.8, right? So of course, it's nowhere close to any kind of review or merge or anything yet, because these capabilities don't exist today. However, still, it's useful for a presentation perspective. That's just treat this as a presentation material, not actual code or anything. Okay, so remember in ABN, the idea is to use a business metric rather than an SLO, like a system metric, for like a latency or error rate, right? It's something like how much revenue your application is getting. And that's the kind of experiment that we want to do, that compares multiple versions and picks a winner based on your business metric. That's the goal of ABN testing for in everywhere, and including Iter8. Now, when it comes to ABN testing, I think we can distinguish between two cases. One is, are you testing a backend service, or are you testing a front-end service? It makes a big difference in terms of the user experience and also in terms of the architecture when it comes to testing backends versus when it comes to testing frontends, right? So let's understand the architecture. When you test a backend, so in Iter8, we want to support both. We want to support a way to test backend services, and we want to support a way to test front-end services. But let's first understand the main difference. When you have a backend service, essentially you have a front-end downstream service that is consuming results from the backend service, responses from the backend service, and the users are interacting with the front-end service, right? And you are A/B testing the backend service. This is a very common scenario, and this is the scenario that, for example, your Kserve, Ray all your, TF serving, TensorFlow serving, everything, all the ML serving frameworks are really going after this backend testing, backend service scenarios, right? They all have a way to stand up a backend ML ops service, and it's up to the front end to consume the results from the backend service. This is a very standard model when it comes to deploying ML ops services. So the thing here is that the user is not directly interacting with the backend. The user is interacting with the front end. That means user-related metrics, which is what business metrics are about. Like, did the user buy something? Did the user click? Did the user give me stars? Or did the user rate the experience as good, positive, or neutral or negative? These are all user-specific metrics, business metrics. They are all visible to the front end. They are locked up in the front end, while you are A/B testing the back end. Right, so that's the architecture here, and that's the system constraint, architectural constraint we have to keep in mind. So this is backend A/B testing. How about front-end A/B testing? So once again, you have user sessions, but this time there is no backend service. So you're just or if there is backend service that is not being A/B tested, it is different versions of the front end itself that is getting A/B tested, right? So those are the primarily two different types of A/B testing that we have to deal with. The main thing to keep in mind is metrics, right? Who has visibility into metrics? In the first case, backend case, the backend service that is being A/B tested doesn't have visibility into its own performance. It's the front end that has the visibility. In the other case, everything is packed in together, standalone. It's in some sense easier to work with this version. So in this scenario, so here this is what is getting A/B tested, and the metrics are available in some sense inside the service, business metrics. Right. So the other thing to remember is that your service meshes like Istio or Linkerd or other things, they don't have any visibility into business metrics, which is what A/B testing is about. They are all very good in collecting latency, error rate, and all that automatically, and pushing it to Prometheus. However, they don't have any understanding of business. They aren't meant to collect business metrics, and they don't document any way of doing business metrics. That's something to keep in mind. Business metrics is visible inside here. So here's our take, initial take on how we may want to do backend testing with Iter8, right? The idea is the following. We have, first of all, 3 components, Iter8 components. There is an Iter8 SDK, which is meant to be used as part of your front end. So when you write your front ends, you use the Iter8 SDK. Within it, we'll come back to what it will do for you. And you also have an Iter8 auto experimentation service that actually watches for backend, right? So if you have a new version of the backend, somehow Iter8 knows about it. And that somehow is through this service. It is watching for different versions of the backend, and that's how Iter8 gets to know that you have a new version of the backend. And finally, you have the Iter8 experiment itself that is consuming metrics and declaring a winner. So those are the 3 parts of Iter8 that will enable a backend testing, Abn testing experiment. And let's take a quick look at what these things actually do. And one of the properties that we want to satisfy, right? So you don't want to change the front end code. You don't want the developer to change the front end code each time there's a new version of the backend. Each time you want to do an experiment, you don't want this piece of code to actually change. That's one of the key things we want to ensure. You want to write this code once, and you want to reuse this code independently of when new versions, new backend services are getting released. That's something that we want to, that's a property that we want to keep, because obviously if the front end team and the backend team have to, are tightly coupled, that just makes for, poor experience for the teams, and it's not an agile practice. So you want to decouple the front end and backend teams so that the backend teams can be independently release the new versions of the backend, while the front-end team uses this SDK to collect metrics, route to different backend versions, and collect metrics. That's really what the SDK here is doing. It's routing. It's kind of through this AutoX service, the SDK knows which versions are available. So through that SDK, the client here, front-end client, can send requests to different versions and also register metrics. So I sent a request to that version and I got a response, and the user did something with it, and I have a metric, business metric, that I can associate with V1, and that metric is getting pushed back to this service. And same thing, I have V2, V3, I send some requests to V2, I send some requests to V3, and I can track metrics for V1, V2, V3, and I send it to the metrics. So to this AutoX service to keep the metrics around. And the experiment itself is going to work with the service to get the metrics and to declare a winner. And there are some interesting things we can do when you have a service like this. You can maybe automatically launch experiments each time there's a new version, watch for it, and just launch the experiment automatically. That makes for an excellent CI/CD GitOps experience. And there are other nice things we can do with a service like this. But this is the basic idea. With the front end, once again, you have similar concepts, but a lot of things become easier. You don't actually have to watch for backends because there are no backends in this case. So you can just use directly. You can just work with different versions of the front end. But once again, you can use the SDK to report metrics. To split the users across different versions here, you can certainly use service mesh capabilities. So that here service mesh becomes useful to define your traffic splits and things like that. However, here, the idea is not to use a service mesh. The idea is to use the SDK because using the service mesh for traffic splitting and using the SDK for reporting metrics start getting very complicated very quickly if you want to do both, because service mesh doesn't provide the right APIs to do stuff like business metrics yet. So we have to invent those mechanisms, which is what Iter8 SDK is doing. Okay, let me pause here and see if there are thoughts. I know this is a lot to take in, and it's a bit of a deviation from 0.7, but let me pause here, see if there are any questions, thoughts. And of course, we'll continue developing the design. Before we write a single line of code, we will keep, making the design better and make sure we get a handle on the design before we start the implementation. However, let's see if there are thoughts, questions. No? Okay. Then I think we're good. Let's keep going. One thing I would add before I wrap up is that, if you develop these kinds of capabilities, automatically, sorry, where did I share it? Yeah, it automatically watching for backend versions and launching an experiment. If you develop these types of capabilities, obviously we'll be able to use them not just for ABN, but also for any experiment, including load testing experiment. So these capabilities are not exclusively meant for ABN. Some of these CI/CD friendly capabilities, obviously they're meant for any experiment that Iter8 supports. So that's the idea. Okay, so that's the only additional point. All right, then let's move on to, I will stop sharing, and I think it's Michael.
Okay. I want to share some initial thoughts on how we might do iterate experiments for Edge. This is a conversation that we started with Paolo Vittori, who's been exploring together with Red Hat how they might implement an Edge application management for Edge, is sort of what he's been looking at. And the way they are thinking about Edge is that at edge nodes, there will be a cluster of some sort running, perhaps a cluster, perhaps something simpler than a cluster that will be able to run applications. And there'll be some mechanism to push applications or get applications to those edge clusters. So his current thinking is to do this in the context of something called Open Cluster Management. Open Cluster Management is an open source project that has its origins in multi-cluster management, which was an IBM effort around private cloud some years ago, and is now part of the Red Hat portfolio. And the idea is that in open cluster management, you have a hub cluster and you have a set of managed clusters, and the architecture is designed so that the hub cluster can support thousands of hub clusters. That's kind of the goal. And so we think of the edge here as being those managed clusters. And this diagram that I'm sharing is just meant to capture some of the concepts that are in open cluster management. So there's this concept
Michael,
of a hub.
You aren't sharing anything yet, just to be sure. At least I don't see anything yet.
What do you see?
I see all of us, which is very beautiful, but not what you want to show, I think.
Yeah, I don't think you're sharing anything.
Oh, I see. Allow meet.google.com to see your screen. Select screen to share. How do I share the whole? Here we go. Okay. Can't share your screen. An error has occurred. I see. I hit share and you know that warning came up on the top bar there.
Sri, I think you said something, but you were muted.
Can you let me in again?
Yeah, sure.
Okay. I switched browsers this morning. Apparently that was the problem. You can see it now?
Yep, looks good.
And you can hear me too, even better. Okay. So this is a diagram meant to show this architecture. The pink boxes are kind of the hubs. So are the clusters. So we have a hub cluster and two edge clusters or managed clusters. And this is just to sort of get us a sense of what are the key concepts in open cluster management. So in open cluster management, the hub cluster is sort of the management cluster. And a namespace is created on this cluster for each of the managed clusters. So here I have two namespaces and therefore for each of the following clusters. And if I want to put some objects on a managed cluster, if I want to put something on cluster 1, I create an object called a manifest work object, which is really a wrapper around some YAML definition of some objects. So if I want to deploy a service and a deployment, I'd wrap them in this manifest work object. I'd put it in the namespace for cluster 1. And an agent running on cluster 1 will discover that it's there, and it will pull the manifest work object down to the cluster. It will create what it calls an applied manifest work object, which is kind of like a copy of it. And from it, then create the service and the deployment on cluster 1. And if I want to create the same objects on cluster 2, I'll create a second manifest work object in the namespace for cluster 2, and then those objects will eventually get created on cluster 2. And so it's really a pull model. To manage, I put things in these namespaces, and the clusterlets in the managed clusters will pull those things, discover them, and pull them down. Now, in addition to this concept of a manifest work object, OCM comes with a couple of other concepts called a managed cluster set, which is meant to be a notion of a set of clusters, and a binding that binds it with a local namespace. And in that local namespace, you can define what's called a placement. And a placement is really a set of rules about how to select a set of clusters. So that might be label matching, it might be some value matching, it might be some resource requirements. So that's the other sort of key concept in open cluster management, is this idea of a placement. And when you create a placement, then open cluster management will create a placement decision object, really just lists the clusters that it's decided meet your requirements.
Michael, who uses OCM? Is it just IBM Cloud?
So it is part of the Red Hat. So Red Hat is using it for managing for solutions that manage clusters and hybrid clusters. But it is as an open source project, and there is a community around it. There are others who are beginning to look at it and use it. Exactly who they are, the set of them, I don't really know for sure how much they're using them. For example, the Ant group in China seems to be interested in trying to use it. I don't know how much they've been successful at it. As an open source project, it is been in the past year that it was open source.
Paula mentioned something about Verizon using it also and trying some GitOps stuff.
Yeah, that's right. Verizon also tried it. Yeah. That's right. Paolo described some challenges they had with it. So let me go back to sort of this scenario. By itself, a placement is sort of disconnected from this concept of manifest work. The fact that I define a placement doesn't mean there's a way to get objects in each of the clusters. So these are kind of separate concepts in open cluster management itself. In order to take advantage of a placement, you sort of have to combine the placement decision together with this idea of manifest work. Use the placement decision to create manifest work in the right namespaces. And so you need something else to do that currently. Now, open cluster management does come with some things, what they call add-ons that do this. But what we're looking at together with Paolo is a controller to work with something called an app bundle. An app bundle is just it's a wrapper around a collection of resources, definitions of resources, but it's defined at the cluster scope, as it were. And then a controller for an app bundle looks at the placement. It's associated with the placement. It looks at the placement decision and will create these manifest work objects for you. So I create an app bundle, I associate it with a placement, and the controller creates manifest work objects. The objects get created in the clusters that I want them to be created in. Does that make sense? Okay, so what does it look like to do iterate experiments in this environment? So the sort of first example we're thinking about is an iterate experiment that really is just, at its core, is just validating that new versions of applications are successfully deploying on some subset of the clusters. So I start with an application deployed on a set of target clusters, and I deploy a new version to a subset of the clusters, and I'll call that some test clusters. And then I run an iterate experiment, and this experiment validates that the new version has successfully deployed. So to do this, it will look at either a status of the app bundle resource itself or at statuses of these manifest work objects. And if it's successful, then if the new application has successfully deployed to a sufficiently large percentage of them, perhaps, then we'll go ahead and roll out the new version to all the clusters. And so just sort of picture sense, I'm going to run through 5 or 6 pictures just to give you this idea. So I have an app bundle on my hub cluster, and as a result, I have some application on a whole set of target clusters. I want to create a new version, so I create a new app bundle. I create this using the same app bundle I use for prod, but maybe, and here I've sort of got an example of how you might do this with Helm. You're going to change the placement, so you're going to change the set of clusters that you want to deploy it to. You're going to change maybe the image of a deployment that you're using because it's a new version, and of course you're going to give it a new name, so because you're creating a new app bundle. And once you've created this, this new placement means that we will be placing these objects that are defined by it down in this set of clusters. Now, by creating it from the same app bundle, all of the resources have the same names. So if I have a deployment named D in my original bundle, I have a same deployment named D in my candidate app bundle. And so when I push that new version down, what I'm really doing under the covers is just updating that deployment. I'm not creating a new deployment. I'm actually just updating the one that's there. So in effect, I am deploying a new version of my application, new versions of those resources in the test clusters, and I'm leaving the original ones in the rest of the clusters.
So Michael, you mentioned that there's an app bundle controller, right? So that watches the app bundles getting created and then create these work manifest. So now that you have 2 app bundles, the original one and the candidate one, so the controllers knows how to create a single?
No, it's creating 2 manifest work objects.
Okay.
So this one created a manifest work object for each cluster. This one creates a manifest work object for each of the test clusters. So in each of the test clusters, I now have 2 manifest work objects, and they're pointing or they're defining the same set of objects. Yes.
Oh. Okay.
So in a sense, these objects down here on the managed clusters, they have two parents.
Mm-hmm.
Okay, and that's okay. That's actually a good thing for us.
So the work manifest is there's a one-to-one relationship between a work manifest and the actual deployment in each of the clusters. But
Yeah. So if I have one app bundle and I want to deploy it to two clusters, cluster 1 and cluster 2, I'm going to create a manifest work object in each of these namespaces that correspond, one for the copy that goes into cluster 1 and one for the copy that goes into cluster 2. So there's a one-to-many relationship between an app bundle and manifest work objects.
I see.
But within a given cluster namespace, there's a one-to-one relationship, yes.
Okay.
Yeah. Okay, then I would run this iterate experiment. What I expect is that the experiment would have some set of properties or parameters that look something like this. So there'd be a timeout. How long are we gonna wait for these objects to be created? Do they get created in a timely enough manner? What's the bundle that I'm deploying that contains my new version? That's the bundle that I want to check status on, or figure out how to check status on those objects. I may not look at the bundle itself. I may be looking at manifest work objects. What placement is used for it, so that I can determine what clusters I need to be looking at results from. And then maybe something like a success rate. What percentage of those test clusters need to successfully have the application deployed? In an edge environment where the managed clusters are pulling, we may not ever expect to always have 100%, but we may require as a service level objective to have something like 95 or 98% in a test scenario.
Hey, question, Michael. So the app bundle looks like the app bundle and placement are decoupled from each other, right? So you can combine an app bundle with the placement choice, resulting in, I guess, manifest works.
Yeah, today the app bundle definition, so let me just show you an example of one. Here we go. An app bundle definition, you actually include in the definition of the app bundle, you use a label to associate it with a placement. This is the way the mechanism works today. And so the app bundle itself is in fact tied to a placement, but it is something that you could change. You can edit this and you could change this placement. Right.
The reason why I asked was your command had both app bundle and the placement in it.
You're right, and that's a very good observation, and is probably not necessary.
Okay.
Yeah. You're right. Okay. So once the experiment is successful, we can go ahead and update the original app bundle that defined the application, and we can update it using, again, say, this new image. And so by redefining this app bundle, the app bundle controller observes that the bundle has changed, and it goes and updates the manifest work objects that it had created in the past. In turn, that triggers the managed clusters, all of them, in this case, because it's the original bundle. So it's the original placement, meaning it's all of the target clusters. Each of these sees that change and will update the objects that it's managing. So the new version will be deployed now across the board. Now, that's clearly going to happen in those clusters that were not in the test collection. What about the ones in the test collection? Well, in fact, nothing changes in this case because the new version is already there. The new YAML definition that's being provided matches what's already deployed. So the test clusters don't change, but the additional clusters are now upgraded. Finally, we can delete this candidate app bundle that we were using for the test. As we said, all of the test clusters, the objects kind of have two parents. There's two manifest work objects and there's two app bundles. When we delete an app bundle, the manifest work objects for them get deleted. In turn, down at the clusters, then there will be an effort to delete the objects that are associated with that manifest work object. Now, what happens is if we look at these objects themselves, these objects have two owners. So Kubernetes objects have a notion of an owner reference, which identifies the owner of the object. And you can have multiple owners. And so these objects, in fact, have multiple owners. And so when we delete one of the owners, we go ahead and we delete it. But the other owner remains, and so the object itself remains. And what we've done now is we started with an initial deployment of a new version. It's too many words. We started with the deployment of a new version to a subset of clusters. We ran an iterative experiment to verify how well we deployed them. And on success, we rolled out the application to the rest of the clusters. And so this is kind of our initial thoughts on experiments. And I wondered if there were any questions or feedback.
So Michael, when you talked to Paulo about the edge computing scenarios, I'm wondering, what do the existing users of OCM do without automation tools like Iter8? Do they just do everything by hand, or do they use scripts? What's the current practice?
So let me show you sort of how they document, for example, how users might want to upgrade applications. This is kind of their notion of this, and they're doing really what amounts to a GitHub example. And so they have a notion that on my hub cluster, I will create a subscription to GitHub, to a GitHub repository, because I'm going to do some kind of GitOps. And what my hub cluster is going to do, I'm going to have an add-on, an application add-on that takes that hub subscription, and it's going to push it down to each of my managed clusters, creating a local subscription to that same repository. And so the way I'm going to deploy applications here is I'm going to modify it in GitHub, and all of my managed clusters are going to be seeing that change. They're going to pull the change. They're going to implement the change. And so it's a very distributed model. This is something that apparently Verizon is trying. And what they discovered is that they have thousands of clusters, and all those clusters try to hit public GitHub, and public GitHub doesn't like it. So they're looking at redoing that model, where they're not going to push the subscription down. Instead, at the hub model, the subscription will see changes, and it will create a set of manifest work objects similar to the way the app bundle is creating manifest work objects. Or alternatively, maybe it will create an app bundle object. At present, app bundle is not an OCM concept. That is an extra concept that Paulo has been creating. Does that answer your question?
Yes, thank you.
Yeah. So I want to sort of point out that this use of OCM, we are sort of doing this in OCM. We have added stuff on top of it, but OCM by itself isn't necessarily completely suitable for Edge. So Paulo has been exploring, other concepts that are needed. For example, when there are thousands of clusters, the Kubernetes database, SED is not really satisfactory. So how can they replace it? There are mechanisms that they use to replace it. But in turn, that means really what he's doing is creating a virtual cluster in order to support that. So these are various set of related changes taking place to OCM. Some of which may make it into OCM and some of which may not. We don't know. Any other questions or comments?
This looks like a very interesting application of Iter8. The way you're describing it with the OCM and edge rollouts. One thought I had was we can flesh out our sequence, your first Iter8 OCM experiment. So we can flesh that out a little bit and actually go to the OCM community meeting, put it there, and just say, hey, folks, we want to show you something we're working on. What do you think? And we can get their direct feedback before we go too far ahead, because then we gives us a chance to course correct if necessary, right in the beginning. That's one thing. And the other thing is, you mentioned app bundle is not a OCM concept. So perhaps app bundle obviously is a nice concept, and obviously it has its advantages. It's clear. But in the interim, we may have to think through how maybe just use Helm or something like that, template the bundles or whatever, or for the time being. So we may have to think through what your first experiment in OCM with Iter8 means without app bundle, right? Because if we take them to OCM, I mean, we don't want to put a dependency on app bundle. That's what I'm trying to say. In order to find usage in the OCM community, we don't want to be in a situation where first app bundle has to clear their hurdle and then Iter8 clears their hurdle on top of app bundle. We don't want that, two-level clearance. We just want one-level clearance that is iterated by itself, provides some value, and here's how you use it with OCM. So I think we may have to play that game also a little bit better.
Yeah, we can look at whether there's an easy way to translate something into manifest work objects.
Yep.
Typically, this requires sort of some kind of controller. The app bundle controller is something Paolo has created, and he is hoping to, again, go over that barrier and submit it to OCM. But as you point out, there is a wait. Anything else, again, is typically done with what they call an add-on architecture. You add a controller to the hub, and you can add agents to the managed nodes as well.
Or maybe we just put it together. We present app bundle and Iter8 rollouts together, and
maybe
we make a plan to approach that OCM community.
Right.
This is one, layer it this way and then offer it this way.
Right.
So the benefits.
It's a concrete way in which it's clear what the benefits of Iter8 are.
Yeah.
I think it's straightforward to see how it might apply in other application rollout scenarios, but it requires some change. Yes.
Yeah.
Yeah. And then beyond that, we can also begin to think about, this was an experiment that really just did validation. A lot of what we've been talking about are about load tests. We can begin to ask ourselves, how would we actually do a load test with Iter8? And this is yet another problem that maybe we'll save for another time, since we only got 3 minutes left.
Okay. Or you can get our 3 minutes back then.
Okay.
Bye, everyone.
Bye-bye.
See you.
Bye.